Welcome to video number 4 in our series on solving quadratic equations. I have a warm-up problem for you today. Ask you what are the zeros of the equation y equals x squared minus 11x plus 18. Zeros, it's a word hopefully we've used by now in class. I haven't used it in one of the videos yet though. Zero is just another word for solutions, for x-intercepts, for places where our graph would cross the x-axis. There are places where y is 0. So when I ask you to find the zeros of that equation, I'm asking you to make y 0, just like we do for an x-intercept and solve. So I'd like you to try to solve this on your own now. Okay, hopefully you've done that. And we know we're going to factor this down. We've learned some tricks to kind of cut down on the amount of time it's going to take us to look for different factors. We know x times x, certainly for x squared. We know this sign being a plus means the signs of our factors will be the same, and they will be the same as this sign here. So they're the same, but they're both minuses. So I have x minus and x minus. We need two numbers that multiply together to get 18. 1 times 18, 2 times 9, 3 times 6. We're looking for the one that will give us an 11x in the middle, and 2 times 9 will do that, right? Negative 9x, negative 2x, we've got a negative 11x. So we match that up. Then to find those zeros, those are our solutions. Those are our x-intercepts. We set each of our factors equal to 0. And we find that x could be 2 and x could be 9. Right? Hopefully you got the idea there. If you did, you're in good shape moving forward in the activity and in the lessons. I want to extend this and look at solving some different quadratics today. I have an example for us here to look at together. 5x squared minus 55x equals negative 90. Now the first thing you should remember is that right now we can't factor this. There's something important that we need to do before we start to try to factor. Remember that our equation always needs to be equal to 0. So we need to add 90 to both sides. Now we have two things going on here that are a little bit confusing or disappointing if we have to solve this problem. First thing is the 5 out front. Everything we've done so far has just been x squared out front, and so we immediately knew x times x for the first part would give us x squared. So dealing with that 5 might be an issue. The other issue is 90 has a lot of ways to break down. You know, a lot of different pairs of numbers we can multiply together and get 90. So a lot of things going on that could be difficult there. We should be able to tell the signs will be the same and they'll both be negative. But what I want to talk to you about today is an extra part of factoring. Looking for something called a common factor. We're looking for something in each of our terms that's in common. And if you look at the 3 terms in this trinomial, in this quadratic that has 3 terms, you'll notice there's a number that will divide evenly into all 3 of those terms, and that's the number 5. So here we have a common factor of 5. All right? What we're going to do is factor that 5 out of the equation. It's like doing the distributive property backwards. All right? So think about if that 5 were out front here, we're still going to be equal to 0. If that 5 were out front, let's think about, well, 5 times what would give me 5x squared? 5 times x squared. And then how could I get a minus 55x with the distributive property? It'd have to be 5 times a negative 11x. And then, well, 5 times what would give me 90? If I do 90 divided by 5, I get 18. All right? So we've taken out that 5 as a common factor. The advantage of doing that is we've got something that's a lot easier to deal with. We've got smaller numbers. We've got a regular x squared out front that we know how to handle. Right? That 5, we'll talk about how that 5 as a factor works out when we end up finding the solutions to this. But look how convenient this is. Not only is this something that we're comfortable dealing with. It's something that just by coincidence, not really, because I made it up this way, it's something we've already factored. In the warm-up, you factored x squared minus 11x plus 18, and that same expression shows up here. So we already know that this is going to factor into x minus 2 and x minus 9. So those are our factors for our equation. Just like we did with all the other problems that we've solved for x, we set each of our factors equal to 0. We still take this x minus 9 factor, set it equal to 0, and then we add 9 to both sides, and x is 9. We still set x minus 2 equal to 0, and x is 2. Now, this common factor is still a factor, so we do still have to make sure that there aren't extra solutions there. So we would also set whatever this factor is equal to 0. I could set 5 equal to 0, but 5 doesn't equal 0, ever. That's just not true. So that doesn't give us an extra value of x, doesn't give us an extra solution. We still just had two solutions in this case, x equals 2 and x equals 9. All right? Doesn't mean these are the same equation. You know, if I think about graphing this quadratic versus the one in the warm-up, they'll have the same x-intercepts, but they will look slightly different. And if you remember a little bit about transformations from before, you'll know how. If not, that's something we're going to be looking at later on in this unit. So looking for that common factor is a great way to simplify problems and make them easier to solve. All right, here's another example that we'll do together. Still a quadratic, still got that x squared there, but we're missing a term. You know, we're used to having what we call a c value. We're used to having that constant, that regular number at the end of the expression. So we don't have that here. You could tack on a plus 0. You could think of it as x squared plus 5x plus 0 equals 0 and factor it down that way. But what's easier to do is look at the fact that we only have two terms now here, and those two terms have something in common. They have a common factor of an x. There's an x in both of them. So we're going to factor that x out of our equation. We're going to take out that common factor. And we're going to think about, well, x times what would give me x squared? X times x would give me x squared. And x times 5 would give me 5x. And I've already got that factored, right? Just by taking out that x. I still find x, I still solve. I find the zeros or the solutions or the roots or the x-intercepts by setting each of the factors equal to 0. So this x counts as its own factor. So we do set that x equal to 0, and we have x equals 0. And we have x plus 5 equals 0. And then we subtract 5 from both sides, and we find that x could be negative 5. Two solutions again. Remember when you take that common factor out to consider what would make that expression equal 0. In this case, x equals 0. Last time we just had 5 equals 0, which gave us no solution. All right? So looking for that common factor is a great trick to kind of simplify a problem for you. So you don't have to deal with large numbers. You don't have to deal with missing terms, like a missing constant here at the end. And you can quickly simplify the problem. Right? What I want to wrap up with is one problem for you to try on your own. To see what you can do about solving this one on your own. Take a second to pause and try that. All right? So looking for things that these two terms have in common. There's definitely an x in there. You can see that both of the terms have an x. There's also a number. Right? There's also a numerical common factor. Now there's a lot of different numbers that go into both of them. Just you can notice that 2 goes into both because they're both even. They're both factors of 4. They're both factors of 6. If you find any of those factors, that's fine, as long as you get that x out of there. But what's best is if you could take out the greatest common factor. I'm going to show you how that would be better. Let me first just say, what if I only noticed the x? I know that x comes out. And this would become 12x minus 72. I would set my factors equal to 0. I would set x equal to 0 and have a solution. I would set 12x minus 72 equal to 0, and then by adding 72 and dividing by 12, I could get that x is 6 there as well, and I get my two solutions. So as long as you take out a common factor that includes the x, you can get the solutions here. What would probably be quicker and easier if you notice that a 12 will go into both of those. So instead of factoring it that way, over here, I'm going to take out not only the x, but also a 12. I'm going to take out the common factor of 12x. Need a little bit more room there. If I take 12x out of 12x squared, I've just got an x left. If I take 12x out of 72x, I get a 6 left over. So now when I set my two factors equal to 0, 12x equals 0. Well, to solve for x, I'm going to divide by 12. And 0 divided by 12 gives me 0, which is one of the solutions we saw here. And x minus 6 equals 0. Obviously, that means x equals 6, which is the same solution we found there. Two different ways to solve the same problem. As long as you take out a common factor that has the x in it, you're okay. You can take out what we call the greatest common factor. Take that 12 out along with the x. It's going to make the problem a little bit easier to solve at the end. But what you'll notice is regardless of which way you did that, you're going to get the same solutions at the end. Okay? So a couple new techniques of looking for greatest common factors to simplify that we'll try out in class tomorrow.